Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where I am trying to help you to achieve 60 in your upcoming KCET 2025 exam. And if you are following me from the beginning, you should know that we have already completed all the chapters of PU2. So next time onwards we will start doing the revision for PU2 very soon. But right now I am going to discuss the second chapter of your PU1, motion in a straight line. So motion in a straight line is going to be our current chapter for today, and this is a small chapter, so I will try to complete this chapter quickly as soon as possible. Before I go any further, you have to download our WhatsApp channel. You have to download WhatsApp and join our WhatsApp channel if you have not yet done so, because every week we are doing KPL, KCET Premier League, absolutely free of cost. For that you have to join our WhatsApp group, where all the updates will be shared, all the question paper will be shared, and I will discuss the answers after you answer those questions. Now let's look into the detailed topic of today's lecture. So what all we are going to discuss today? We will start with average velocity, one of the important topic. Then we will discuss instantaneous velocity or instantaneous speed. This is the most important concept from this chapter. Then we will see average acceleration, and then instantaneous acceleration as well. Then kinematics equation, 3 kinematics equation, and that will not only help you in this chapter, they are going to help you in all the other chapters as well. And then motion of an object under free fall, that's just a graph that is there in your syllabus. We will discuss that as well, and with some examples from your previous year questions. This is a small chapter, so hopefully I will be able to complete it very quickly. So let's start with average velocity. So what is the term means average velocity? Let's see. So average velocity is given by total distance traveled by total time. Okay, so total distance traveled by total time. Okay, so basically instead this is total, this will be average speed. Okay, this is not velocity. Total distance traveled by total time is average speed. Average velocity is it is also denoted by the same symbol. In this case, total displacement by total time. Why the difference? What is the difference between displacement and distance traveled? Displacement is a vector quantity, and total distance traveled is a scalar quantity. So average speed, when you are trying to find average speed, in that case this formula is fine. But when you are trying to find average velocity, total displacement by total time should be the average velocity. Can you tell me one example where average velocity is 0 but average speed is not? You guess it right, when we are moving in a circular path. So suppose one racer is racing in a circular track. So he starts from point A, and when he reaches here at the same point to finish the race, okay, its total displacement is 0 but distance traveled is not 0. Distance traveled is 2 pi r, right? The circumference of the circle. So 2 pi r is the distance traveled, and displacement will be 0. So average velocity will be 0, average speed will not be 0. This is one of the example. Now let's see one problem that came in 2023. A body is moving along a straight line with the initial velocity v0 and acceleration a. The average velocity of the body over the given time interval is. Okay, so average given time interval is not given, but you can assume that its given interval is t. Okay, so body is moving along a straight line. It is moving along a straight line, but it is not only a uniform motion, it is also accelerated motion, right? So uniformly accelerated motion. So initial velocity is v0, final acceleration is a. Suppose after some time t, what is the average velocity? That is the question. Okay, so what we know? We know that the final velocity is not important in this case. So what is important? What we will try to do, we will find the displacement. So what is the displacement? Formula for displacement when an object is moving is given by s equals to initial velocity times t plus half at square. It is accelerating, right? So this is the average thing. But also see here they have also given in terms of final velocity v. So this is not, this equation we are not going to use it. Okay, we will see kinematics equation. There are 3 kinematical equation. This equation will not use. What we will use, v square equals to v naught square plus 2as. Why I am using this equation? Because here the final expression is given in terms of v. Okay, so based on what options they have given, you have to choose the correct formula. So 2as equals to v square minus v naught square, right? Or displacement s is v square minus v naught square divided by 2a. So this is the displacement. Now what is the average velocity? Average velocity is displacement divided by time. So it will be v square minus v naught square by 2a times t. So the correct answer will be v square minus v naught square divided by 2at. Be careful, okay? If you are missing 2, then your answer will be incorrect. Okay, so it will be 2at in the denominator, right? So this is easy question, solvable. If you have just spent maybe 15 minutes in this chapter, you would have able to answer this question. You have not spent the time in this chapter. Now you may be able to still be able to solve this question, but it would take a longer time to answer during your exam, so you will miss out some other questions as well. So try to answer those questions quickly. Now let's move on to the next part, instantaneous velocity. The average velocity tells us how fast an object has been moving over a given time interval, right? But does not tell us how fast it moves at a different instances. Okay, so for different instances how fast it is moving. So for example, it starts from the rest, okay, it accelerates for 10 seconds, then it decelerates for another 10 seconds. So maybe it is moving, we can find the average velocity and we can say, okay, in that time interval this was its average velocity. But that does not tell us that at the end of the 10 second its velocity was maximum. So that information is lost when you are trying to calculate the average velocity. So how can we find the maximum speed, or at every point in time what was its velocity after 6 seconds, what was its velocity after 12 seconds. So that information is not there in average velocity. Average velocity, obviously the name suggests, is the average of everything. Okay, for this we define instantaneous velocity. Instantaneous means at that particular instant. Okay, using this you can find the velocity at particular instant. Okay, and simply in velocity v at instant t, the velocity at instant is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. In other words, you are familiar with this. What is that? That v equals to limit delta t tends to 0 delta x by delta t. Now delta t tends to 0. If you have studied differentiation, so you know that this is nothing but differential of x with respect to t. You have learned that, right? dy dx, where you take delta x by delta y and then you put delta y tends to 0, then dx by dy. Right, or dy by dx. In that case you take delta x tends to 0, delta x by delta x. So that is the same thing. So here you can write this as instantaneous velocity. To find the instantaneous velocity, we are going to use the differentiation. Also in some cases you will be given a complex function of x, then at that point what you have to do, you have to find the velocity by using method of differentiation. We will see some problems today and some problems tomorrow as well. There we are going to use this equation extensively. Okay, now when a graph is given, Okay, when a graph is given, at that time what we have to see is that where is the velocity is, what is the velocity say at point P1, at Q2. So there are different points are given and you are asked to find the instantaneous velocity. So how you can do that? To find the instantaneous velocity at a graph, what you have, suppose we are trying to find some other point, say X. We are trying to find the instantaneous velocity. What we have to do? We have to draw a tangent at this point. We have to draw a tangent, and whatever is the slope of this, okay, that slope will be the instantaneous velocity. Now what you have to do? You have to make this as small as possible. Okay, you know that this is delta t, this is delta x. So velocity is delta x by delta t. Okay, and if you take delta t tends to 0, then it becomes differentiation. This is nothing but slope of the graph at that point. This is nothing but slope of the graph at that point. If it is a straight line, slope is constant. If it is a curve, okay, what you have to do? You have to take a point, and around that point you have to take a duration. And then from that duration, what is the time duration? Delta t by delta x, you can calculate the instantaneous velocity around that point. Okay, differentiation is the most accurate part. If if you are not able to do the differentiation, you can use graphical method as well, even though that is not 100% accurate, but this is very close to actual value, so that is also fine. Now let's see VT graph. This is also another important part of this chapter. VT graph. If you plot velocity along y-axis, time along x-axis, previous graph was xt graph. Remember that xt graph means displacement versus time graph. Okay, here it is velocity versus time graph. So velocity is known for an object. Then if you draw this graph, how the velocity is changing each point, then you get this kind of graph. This is called VT graph. Now what is the importance of VT graph? What is the importance of xt graph? They all have different meaning. Okay, so first of all, the area under the VT graph represents the total distance traveled. So if you can find the area of this VT graph, area under the graph means this is the area under the graph. Okay, so you start here, you end at the end where the velocity graph is ending, and that is called the area under the graph. Okay, this represents the displacement. Okay, in case of xt graph, only the slope is important, but the area under the xt graph is not so important. Okay, area under the xt graph does not represent anything, but VT graph represents the total displacement, right? Area under the xt graph represents, you can calculate the average velocity from calculating the area, but that is a different issue. Okay, you can calculate average velocity in a different way also, but this is very important. Okay, from there you can calculate the total displacement no matter how the object has moved. Suppose the object is moved like this. If you can calculate this area, okay, using any method, you will get the total displacement. Okay, this is very important concept. The average acceleration. Now let's look into the concept of average acceleration. This is also another concept similar to that of average velocity. Average acceleration A over a time interval is defined as the change of velocity divided by time interval. So how the velocity is changing within a given interval of time, that is called average velocity, average acceleration. Okay, average acceleration is also again representing the average value. So what we need? We need the instantaneous acceleration. Okay, instantaneous acceleration is defined by, as you know, if you take the time interval delta t and take it to 0, then you will get the instantaneous acceleration. Instantaneous acceleration is dv by dt. For time varying velocity or time varying displacement, when it is changing with time, only way to find velocity, only way to find acceleration is to differentiate. So differentiation is very important. I know many of you, when you studied this chapter in your first PU, you are not so much familiar with differentiation, you are not so much familiar with integration. So most of you have some backlog related to this chapter. So I request you, go through this chapter once, go through this lecture once, so that your basic ideas are cleared, and the question that comes from this chapter are very basic. If you know how to answer it, you can answer those questions easily. Okay, now there are three equations of kinematics. What are all those equations? First equation is this: V equals to u plus at, the first equation. You are learning this equation from very young age, okay, when you are in 7th standard or 6th standard. From there you are studying this equation, okay. Next equation is s equals to ut plus half at square. This is also when you are in, I think, 10th standard you have learned, or 9th standard, I think 9th standard you have learned this equation, s equals to ut plus half at square. And third equation is v square equals to u square plus 2as. These are the three basic equations. These three equations will help you no matter what competitive examination you are preparing for. 1 to 2 questions will definitely come based on these equations, where you have to apply this equation. So these equations are very handy, and where you will use this equation based on 2 things, okay. What all are given, what all values are given, what all variables are given, what all variables are given, okay, and what are you trying to find. What are variables are given and what you are trying to find. And in some case, like the question we have seen, in case of some cases where what you are trying to find, what you are trying to prove. Okay, sometimes based on the result we can choose whichever option, whichever equation we want to use. For example, in the question that we have solved, in that problem the velocity, final velocity was given, so that's why we used that equation. If the final velocity was not given but instead some other form was given, based on that form we would have used a different equation, right? So what all are given, if it is given in particular way, based on that we have to use the correct equation, okay. Here you obviously, I hope you know the symbols. U is initial velocity, v is final velocity, a is acceleration, t is time, s is displacement, right? Now let's look into one question that came in KCET 2017, little older question but very relevant question. A car moving with a velocity of 20 meter per second is stopped in a distance of 40 meter. Okay, so a car, suppose there is a car, it is moving, okay, with a velocity of 20 meter per second, okay, and when it is stopping, it stopped in a distance of 40 meters. So you apply some retardation to it, okay, you apply some retardation to it and it stopped at 40 meters, okay. Next is the car is now traveling traveling with a double velocity, okay, the distance traveled by it for the same retardation. So distance traveled by it for the same retardation, but they have missed one trick here. They should have given one option which is equal to 80. Okay, I can bet that many students would have answered that 80. This is not A, this is only M. Okay, many students would have answered the 80 without reading the question, because velocity is doubled, so retardation will distance travel will also be doubled. So but that is not the case. So they have given you enough hints, enough possible answers. Let's see which formula we will use. So first case, velocity was 20 meter per second and it is stopping at a distance of 40 meters. Second case, retardation is same as they have said, for same retardation, okay, velocity is doubled now, the velocity is 40 meter per second. Okay, now what will be the distance in this case? Anything is given about time here? Any information about time is given? It is not given, right? Initial velocity is given. Also, when it is coming to a stop, what is the final velocity? Final velocity will definitely be 0. Both cases, final velocity will definitely be 0. So if something is moving and it is coming to a stop, that means its final velocity is 0, right? Acceleration is not given directly, but from the first information we can calculate the acceleration. Okay, and we can apply that acceleration for the second case and we can find the distance traveled or displacement. Now, as I said, time is given in any equation, time is not given. So what formula we will use? There is only one formula that uses anything without time, that is v square is equal to u square minus 2as Why I am writing minus? Because it is retardation. That means it is coming to a stop. That means A is negative acceleration. That's why there is a negative sign here. Now final velocity is 0. Initial velocity for the first case, we are applying for the first case. Okay, for the first case, initial velocity is 20 square minus 2 times A times S is given 40. That is also given. Okay, so now let's see what we can get. We get 0 equals to 20 square is 400 minus 2 times 40 is 80 times A. So what is A? A equals to 400 divided by 80, okay, or 5 meter per second square. You don't need to use the unit, but I am writing it for your convenience. So we have calculated the acceleration. Now we will use the same equation, v square equals to u1 square minus 2s1. Okay. Now the velocity, initial velocity is changed, final velocity is again 0, initial velocity is now twice that of initial first case, that is 40. So 40 square minus 2 times A we have calculated is 5. So 5 times S we are trying to find now. Okay, so we are trying to find S now. Now what is the value? So 10 S1. 5 to the 10 S1 equals to 40 square. What is 40 square? 4 4 is 16 and there is 1 0 2 0. So 1 0 square means the number of zeros gets doubled. So S1 equals to 160 meters. Okay, so the correct answer is option D. Okay, not 80 meters, not 640, not 320, it is 160. Okay. Be careful while answering this question. The options in this question are so obvious that you can even guess it will be 160. Okay, 320, 640 will be too high, but you can guess the answer even if you are not doing the calculation in this case. But if they had given you 80 meters, then I think 90% of the students who are guessing the answer, they would have guessed it wrong. Right? Now, the last part is the motion of object under free fall. So when you take one object, okay, and you then allow it to fall under the motion of gravity only, okay, then it is called a free fall. This is a state of free fall. So for example, if you take a stone and if you drop it like this, then it is called a motion of free fall. Now, in case of free fall, what is happening? Initial velocity, initial speed or initial velocity is 0. Okay, and it is accelerating downward. It is accelerating downward with a fixed acceleration, that is acceleration due to gravity, okay, which is equals to 9.8 meter per second square. But for most practical cases, you will consider this as 10 meter per second square. Okay, this is called free fall. Okay, so no other force is acting on it other than the gravity. Okay, but when you drop an object in normal atmosphere, okay, there is a viscous force, drag force acting on it, but in case of free fall, we assume that there is no other forces acting on it. Okay, every object under free fall accelerates with the same acceleration, and if you plot the graph of velocity versus time, okay, then you will get this graph like this. Okay, this is displacement versus time graph. This is displacement versus time graph. Okay, why this graph is negative? Because as you are going down, generally this is 0. Okay, if you consider this is y axis, y dash, okay, this is your 0 origin, that is from where you are dropping it, and as you are dropping it, it is going down, so its displacement is negative now. Okay, and its velocity is a straight line, it's increasing in a straight line. Why? Because v equals to gt here. Okay, but you can add a negative sign because it is increasing in the downward side. So velocity is increasing constantly with time, right? So in velocity is increasing, it's a straight line, but for displacement it is a parabola. This is an equation of parabola because s equals to half gt square. I hope parabola is done. In your mathematics class, you know that this represents a parabola equation, parabolic equation, y is equal to 4ax square. So it's the same equation. Okay, you can find the latus rectum also, but this is a parabolic equation, this is a straight line equation. And let's see one more problem. A body falls freely for 10 seconds. This is from KCET 2027. A body falls freely for 10 seconds. Its average velocity during this journey, take g is equal to 10 meter per second. So as I said, here you have to take g as 10 meter per second, and it is falling for 10 seconds. So what is the average velocity? What to do? We have to first step, when you are calculating average velocity, first thing is to find the displacement. Displacement is ut plus half gt square. Now u initially, u is 0, so 0 plus half, g is 5, and what time it is given? 10 seconds. 10 seconds is given, so 10 square. So it will be 5 by 2 times 10 square, that is 100, so it will be 50, so it will be 250 meters. Now what is the average velocity? Average velocity is total displacement divided by time, so 250 divided by 10, that is time, so it will be 25 meter per second. So 25 meter per second. So now let us put the values. S we are trying to find. U is initial velocity is 0, half, gravitational acceleration is given as 10, and time is also given as 10 second, so 10 square. Now let us find the displacement. So displacement will be 5 into 10 square, that is 500 meters. Okay. Now what is the average velocity? Average velocity will be displacement divided by time. Time is 10 second. Okay, so 500 divided by 10, that is 50 meter per second. So 50 meter per second is the average velocity. I think units are given in these questions are wrong. Okay, it is misprinted, so it should be -1. Okay, so correct answer is 50 meter per second is the correct answer. So I hope you have enjoyed this lecture today, and if you find this lecture useful, don't forget to share with your friends and like this video. I'll be back with PYQs and some more extra questions for this chapter tomorrow. Till then, tata, bye bye.